So we've covered the basics and the introduction to integration topic. What this is allowing us to do is start to integrate simple expressions, see where all this comes from, and work with it a bit more effectively. What I'm going to do here, I'm going to pose you a few questions. What I want you to do is read the questions, think about them, pause the video, have a go at them, and then come back and see if your answers match up to the working I'm going to do for the questions. So here are the questions I'm posing you. I want you to integrate the following three expressions. So first one is f dash of x equals 2x to the power of 5. Second is f dash of x equals 6 over the cube root of x. And the third is dy by dx equals 2x plus 1 over root x minus 9. What I want you to do now is pause the video, take a few minutes, have a go at these questions, and then come back and look at the answers, which I'm going to go over in a few seconds. So the first question was f dash of x equals 2x to the power of 5. Now remember, when we integrate this, what that essentially means is we're trying to find back to our original function f of x. Now when we're integrating, we have to remember to denote it with the integral symbol, which is that. So what we're looking to do is the integral of 2x to the power of 5, and remember we have to include the dx. Now the dx tells us what variable we are integrating with respect to. So this is x, so it's dx, but if these were t's, it'd be dt. If it was a y, it'd be dy. Whatever you're integrating with respect to, this tells you. Now remember, when we did the integral of ax to the n dx, what we said was that was our ax, we raise the power by 1, but we then divide by this new power. But there was a key thing at this stage as well. We had to include a plus c, where this was our constant of integration. Remember, with no limits, we have to include this to show that there may have been something there, we just don't know. So to do this, that's what we have to do with this one. So first thing we do is we write down our a, which is a 2, we do the 2x, we raise the power by 1, which is 6, and we then divide by this new power. So we get 2x to the power of 6 over 6. We then include the plus c. Now I can simplify this a bit here, and I can simplify that to f of x equals x to the power of 6 divided by 3 plus c, my constant of integration. And if you wanted to check this, you could go and take the derivative of it and you'll get back to the original function. But that's me integrated that expression there. Second question, f dash of x equals 6 over the cube root of x. Now, when we're doing something like this, it's a similar theory to differentiation. It has to be written in some sort of form of ax to the n. So constant times x to a power. It has to be written in that form, so we have to modify this a little bit. Now remember, cube root means that I've got a fractional in this, so it means I've got x to the power of 1/3 in this case. And now it's on the bottom, so we then have to bring it up. But remember, when we do that, our power turns to a negative. So we then know that f dash of x equals 6x to the negative 1/3. So now it's written in this format here, I'm able to now just do the integral. And it doesn't change just because there's a negative power or because it's a fraction, it's still the same technique. It's still f of x equals the integral of 6x to the negative 1/3 dx. We still start by saying what I'm doing. We then keep going the same way. So I write 6x, I then raise this power by 1, so I get 2/3, and I then divide by my new power, and I then include my plus c. So what I now need to do is simplify it at this stage. So I've got 6 divided by 2/3. Remember, dividing by 2/3, that's the equivalent of flipping the fraction and multiplying. So that's the same as multiplying by 3 over 2. So 6 times 3 over 2, that gives me 9, x to the 2/3 plus c. Now again, if the question doesn't state to you to simplify as much as you can and write it without an index, this is a perfectly fine and acceptable way to leave your answer. So on to the third question I set you, which was dy by dx equals 2x plus 1 over root x minus 9. So I want to integrate this because ultimately what I want to find is an expression y equals. Now again, we have to start by looking at it and thinking, is it in an acceptable format for us to integrate? Well, this first term, the 2x, that is. And final term here, the constant, the minus 9, that's spot on. But 1 over square root of x, no. We have to change that. Remember, it has to be x to the power of n. Well, square root of x, we know that's x to the power of a half. It's on the bottom, so we bring it up, so it becomes x to the negative a half. So that gives me 2x plus x to the negative a half minus 9. Now that it's in that format, now I can integrate it. So now, what I'm looking for is y equals, well, we just have to write it in the integral. So y equals the integral of 2x plus x to the negative a half minus 9 dx. Now that it's written like this, we have to remember what we said about integrating multiple terms one after the other. We integrate each of them on their own. It's actually that straightforward. So I'd be able to say, fine, so I know y equals the integral of 2x dx plus the integral of x to the negative a half dx, take away the integral of 9 dx. Then just go along and do each term one by one, and I'll get my final answer. So integral of 2x dx is 2x squared, we then divide it by 2, plus we've then got x to the negative a half. We write down the x and we add on 1, which becomes a half. We then divide by that half. We then take away, well, the integral of any constant is just that constant times x. And then again, the important stage at the end, plus c. With no limits, we have to include the plus c. We can then just go along and simplify each term one by one. So 2x squared over 2, the 2's cancel and I get x squared. Dividing by a half is the same as times them by 2, but remember x to the half is the root of x, so that just gives me 2 square root of x minus the 9x plus the c. So there you go, I've integrated it and I've got my expression y equals all this here, including my plus c at the end. Remember that plus c, that'll cost you marks in the exam. If it's an integral question without limits where you can't get a specific answer, include that plus c so that you know that it's there. Hope that went well. I will see you in class.